I have also pressed record. Okay,
Okay.
here we go. Astronomy Cast, episode 571, Extreme Binaries. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain, publisher of Universe Today. With me, as always, Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. It is finally spring, as in I can go play in the garden. How are
Yes.
you doing up there in Vancouver Island?
Vancouver Island, yeah, things are great. The weather is absolutely gorgeous, and same thing. I have been out in the garden. The only downside, the robins get up at like 4 in the morning, and
Oh,
they're breeding at this point, so they're just like chirp chirp chirp. And so I have one that has found the he really likes the acoustics right outside my room, and so
oh
I've been
no.
getting up at like 4 in the morning, and then I have to go and I get up and I have to close the window and then I try to get back to sleep and then I can't get back to sleep. And so yeah, I haven't been getting a lot of sleep because this robin has been singing his little heart out every morning really loud right outside my window. So hopefully he'll find a girlfriend and get lost. But until then, yeah, it's pretty funny. But it's spring. I mean, you can't go wrong.
That is awesome.
Yeah, absolutely. So we're familiar with regular binary stars, two stars orbiting each other. Simple. Of course, the universe has come up with every combination of things orbiting other things. And this week, we look at some extreme examples. All right, Pamela, so let's just figure this out. What is a binary star?
So a binary star is a uh, a noun that needs a plural because a binary system is two separate stars. So a binary star is a system that exists in two stars, and they can come in just about any kind of combination of regular star, compact object, advanced star, baby star, and they form in a whole myriad of different ways. They can either arise out of a single collapsing molecular cloud where they collapsed into their individual little solar systems side by side, or they can gravitationally get caught up together through some activity in their advanced lives. So when you're looking at a system, statistically, it's most common that it formed like that, but they didn't have to.
Right, right. And we can talk about that later on, but I'm sort of imagining that sort of standard formation, this gigantic cloud of gas and dust that's swirling around, and you get like, instead of it all pulling into the middle, it pulls into two separate, like, what are the dynamics? Why doesn't it all just turn into one big star in the middle? Why, how can you get multiple stars orbiting around each other?
So you actually have two fragments in the same molecular cloud
Okay.
to be that these fragments are close enough that they'll orbit one another. Different effects can bring them closer and closer over the years, but they form from two distinct fragments in the same molecular cloud. And the fact that molecular clouds is fragmenting is how we end up with separate stars. So the
Right.
fragmentation isn't unusual. It's just these two are close enough that they got caught up in each other's gravity.
Okay. And so then the vast majority of these situations, you end up with some amount of stuff, like a star's worth amount, or mostly a red dwarf's amount of stuff. But every now and then you end up with an extreme amount of stuff. These are very large blobs of gas and dust. And that's how
And
you get.
sometimes you just end up with two regular blobs that interact in ways that are extreme. So when we talk about extreme binaries today, we're going to talk about a whole lot of
Right.
different combinations.
So it's not just necessarily the amount of material that went into the star and the form that it
Right.
took, but in fact, these stars can interact with each other in really weird ways and cause really bizarre effects that we can see. Okay, well, so let's sort of break this down then. When as you define extreme, then we've defined binary, two stars orbiting each other, and star can be all kinds of things. So let's define extreme. Give me start classifying the kinds of extreme things that can happen.
So when I'm talking extreme events, I am talking about things that radically cause upheaval in the life of a star that could only happen because this is a binary system, that any singular star would not undergo these kinds of, well, really bad millennia.
Right. So you could have a an enormous cloud of gas and dust that could generate a star with 50 times the mass of the sun. It's an extreme star. It will then explode as a supernova in an extreme way, but it
Is not an
that
extreme
is not an extreme
binary.
binary because it didn't have a partner to do something even weirder. So but let's talk about, what some of the recipes you can get.
So
What are the
I think
ingredients? I think we need, let's start with our ingredients and then we'll mix them into different recipes.
the earliest discovered extreme combination that doesn't actually involve an explosion is the Blue Straggler. These are stars that were noticed in globular clusters as being unusually young looking in their lives. And in trying to figure out the origins of these individual blue stars, nothing made sense. And at this point in astronomy, we'd been teaching people and saying to ourselves that the space between stars is so great that no two stars will ever collide. And we were wrong. We were very wrong.
Right. So for the longest time, everyone said, no, no, like, come on, stars are small. Space is big. The chances of two stars impacting each other, not going to happen. Unless you've got a place where stars are buzzing around each other like angry bees and you've got millions, billions of interaction opportunities all the time.
And some of these interaction opportunities lead to binary star systems where the stars get closer and closer through a variety of different feedback mechanisms until one day those two stars they become one in one extreme merger.
So is that the blue straggler, or is a blue straggler just is it a head-on collision, or is it most usually two stars have somehow ended up into orbit around each other, and then they eventually just sort of merge together into some.
Well, this is the fascinating thing is we don't know all the possible mechanisms by which you can get a blue straggler star for the very simple reason that we haven't caught any in the act of becoming blue stragglers. Now, we see plenty of super close objects, super close binary systems where it's hard to differentiate between the two stars. So, it's generally thought that these are stars that caught hold of each other or formed together
Right.
and simply evolved into a single star. But that's still a pretty extreme way to reignite your nucleosynthesis.
Okay, so that's the one example, and you've got two stars, regular stars of varying masses. They merge together, they get blue, they seem like a baby star where there should be no baby stars, and then this star just continues on its life, and eventually it fades, does whatever it's going to do.
Yeah, and this is just the beginning of this kind of star. This is the low end normal version.
Right.
Now, as you increase the overall mass of this system, you get more and more extremes of this extreme in a binary star's life.
Okay, so let's swap out some taste. Let's use some tastier ingredients then for this recipe.
Well, there was a rather awesome supernova that we talked about in a rather recent episode where it was realized that they had a compact object, a standard good old fashioned white dwarf that embedded itself in the atmosphere of its giant star companion. And from within that atmosphere, it acquired all the material necessary to go boom as a type 1A supernova. And the shockwave of this ignited the star it was now inside, creating an exceedingly bright supernova explosion.
Right. And I mean, it's such a crazy idea. I mean, talk about extreme, that you get this this star, this white dwarf, has gone inside the atmosphere of this other star, and then suddenly it's an all-you-can-eat buffet. When normally they're sipping away from some partner, all-you-can-eat buffet, and then kaboom! And it didn't take long, like a couple of 100 years, and then it was kaboom.
And these kinds of situations where you have these massive objects that are interacting together during supernovae may introduce a layer of noise to our understanding of distances within our universe that could artificially be causing us to see dark energy. We don't know yet. I'm not saying there is no dark energy. I'm saying there is noise in the data.
Right. That when you see, I guess at this point we've talked about how a type 1a supernova is this long thought to be very standard candle. It is when a white dwarf gobbles up enough material and it explodes. Well, what do you do when a white dwarf explodes within another star? Or what do you do when a white dwarf has gone through some other process that
Yeah.
force feeds it before it actually explodes? If you were using it as a standard candle to measure the size of your universe, suddenly that's no longer necessarily super accurate. So can we scale up then? Can we feed other things to stars?
Oh yes.
Oh, please.
Oh yes. And it's not necessarily that you're feeding them into stars, but there was an amazing press release this week that came from a collaboration of collaborations in Europe where using a combination of X-ray and gamma ray data and massive computer models, they realized that they can start to explain long period gamma ray bursts as what is one of the most extreme doesn't start out with a black hole binary systems you can imagine. In this particular situation, you start out with your standard carbon oxygen burning massive star.
Right.
You put it in a binary system with a neutron star. So it once upon a time had a companion that was
Right.
even bigger than it
Right.
was.
So you used to have two stars, one explodes, and now it's a neutron star, and it's orbiting around this other enormous star.
And when that second enormous star runs out of the ability to generate energy using carbon and oxygen, its core collapses and its outer layer fires outwards. And this mass that is getting shoveled directly towards that companion neutron star will, at the least, make that neutron star significantly more massive. And in some instances, will even trigger that neutron star to spontaneously become a black hole.
Right.
So now we have one star's explosion making a second star into a black hole because it can,
Mm-hmm.
but it gets worse or more
Or
extreme.
better.
I
Come
think
on. This is better.
worse, better. It gets
Yeah.
more extreme. Let's just go with more extreme. That companion that was minding its own business, having a regular everyday Tuesday or whatever, that has now just become a more massive object. All the plasma and everything around it is going to generate a massive magnetic field with a temporary accretion disk that creates a jet. And it is the jet around the companion star
Right.
that it turns out could be that gamma ray burst we're seeing. So when we see these long period gamma ray bursts, where optically they have a supernova remnant, and in X-rays and gamma rays, they have this very short flare of high energy particles, we're seeing the gamma rays and the X-rays associated with the older original neutron star that may have become a black hole, and the visible light associated with the supernova of that first carbon oxygen massive star.
And I mean, like I'm just wrapping my head around that, right? That you've got these two stars. One goes off, boom, now it's a neutron star going around the star. The second star explodes. As it explodes, it blows out this material. This material runs into the first neutron star. It explodes again, but also it's getting spun up in this magnetic field that as it explodes, it's firing out these jets. And this, I mean, these long period gamma ray bursts are no joke.
Oh
We can
yeah.
have one hit us from across the Milky Way and sterilize life on Earth. Like for us, I mean, maybe the cyanobacteria at the bottom of the ocean, or the, you know, will be fine, the water bears, but surface life is in for a rough time. And that you could be tens of thousands of light years away from this event, and that's how extreme they are. That's mind
And
bending.
and so these extreme binaries are causing extreme effects that they're temporarily brighter than the entire rest of the galaxy. And
Right.
that's a thing
Yeah.
to aspire toward.
And we haven't even, so what happens with black holes? I mean, I sound like a 4-year-old now. Come on, what if you add black holes to this mix?
So so if you just had a black hole hanging out next to that initial star that went boom, it would simply go gobble 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 mine. It's not exactly going to become anything more extreme than a black hole, but that can also be generating a jet with a gamma ray
Right.
burst. So
Well, and so this feeds into a piece of research that I think we talked about, this idea that there have been supermassive black holes seen orbiting each other um, billions of light years away, and there's this regular flash that comes from this enormous supermassive black hole with 18 billion times the mass of the sun, and it has this accretion disk around it of all the material that's falling in. And this second black hole that merely has about 150 million times the mass of the sun is orbiting around it, and as it passes through the accretion disk, it is causing this flare that we can see. I think it's like 2 billion light years away. And so,
so
even when you
in
have,
this case, we have binary black hole star A, former mass A,
yeah,
is creating the accretion disk. So second star is passing through second former blob of mass.
yeah,
Black holes at this size are not former
yeah,
stars. They're former families,
yeah,
galaxies,
who knows what they were.
plethora.
Yeah, yeah,
Um,
yeah. However you get 18 billion times the mass of the sun into one compact area.
so blob of mass that became a black hole A creates the accretion disk. Supermassive black hole B, the smaller, passes through the accretion disk to create the flashes, and this can only happen in this double system.
Yeah. And so, I mean, that's on a vast scale, but there's got to be versions of this on the more stellar scale.
And the trick is finding all of these examples. What we have been able to find are the more mundane objects, the cataclysmic variable stars, where you have a compact companion that is eating mass from its either giant or main sequence companion star. That material gets dense enough on its way to be eaten that it explodes, it ignites in its own thermonuclear reactions. And the flare up in light is that nova. The
Yeah.
word nova is just new star. And so, with these cataclysmic variables, this can happen extraordinarily dramatically. And they come in all different flavors, from just a standard white dwarf that will have things crackling around it to neutron stars. And black holes aren't exactly cataclysmic variables, but the energetics of these systems are constantly flaring out in X rays and generating jets that are just a smaller version of what we see in supermassive black holes. And with a supermassive black hole, it's not exactly a binary system, it's stealing mass from the entire rest of the galaxy.
Right, right.
But in these extreme binary systems, we have the black hole happily, hungrily eating things from any neighbor that gets too near. Now, that's the catch, is black holes don't always eat. We actually had a triple system that showed up in the news recently
Yeah.
that was only found because astronomers were looking at a double star, what they thought was a pair of stars that were probably orbiting each other. And when they went to resolve the orbit of that pair, they discovered no, they can only explain these motions if they add in a third invisible black hole that was not eating. So, not eating black holes
Right.
happen.
And so I think that, I mean, okay, fine. I don't think we want to do another show on extreme multiple star objects. So I'm going to let two stars and a black hole into this show this one time. So
Okay.
the just this analysis, being able to see this, is the way that one of the ways that black holes are even seen, that we even know that they exist, right? How do you know that a thing that has gravity so powerful that nothing, not even light, can escape it? How can you even, because that sounds invisible. So this is thanks to the fact that they do form in binary systems and sometimes in a trinary system, we can discover them in the first place.
And the irony is there could be a whole lot more out there that we don't know about because they are orbiting a single star. And we haven't done the necessary detailed astrometry to see that otherwise singular star move.
Are
So
they
we don't,
orbiting the star, or is the star orbiting them?
it's mutual. It's mutual. The vector points both directions.
Right.
Well,
Oh, if
the
only.
different vectors each point in a specific direction, but
Right. Right.
physics is mutual.
And so this is the kind of candidate object that something like Gaia would find, right? To find these
Exactly.
objects spinning around each other.
They'd have to be wide enough to get sufficient motion. But yes, there could be a whole lot of non jet extreme
Right.
busy eating black holes out there in binary systems that we don't see because we're just not looking.
It's interesting to think about that you know, you look out into space and you see a star, and in fact I think with that triple system you can see it with your own eyes, I think.
You can see the combined light of the two
Two,
regular
yeah, with
stars
your eyes.
in a dark site. It's
Right.
it's
Yeah, it's like magnitude 6 or
it's
5 or 6.
close
Yeah.
to magnitude 6.
And, and so just that idea that you can look up into space and you can see what you think is a star is actually two stars whizzing around each other, is actually two stars whizzing around a black hole. The black hole is the system. And these two stars are the hangers on. But from our eyes, we just see a star. Well, it looks like a star, but actually we're not seeing the true reality of what's in that system. Blows your mind just to think
And there's
about that.
so many things out there like this where you go from eyeballs to telescope to bigger telescope and they just keep splitting. Um, yeah, anyone who says double stars are boring doesn't understand. There's black holes out there, folks.
So we've talked about we've talked about sort of extreme objects interacting with other regular objects. You've got like a
Yeah.
black hole, neutron star, black hole orbiting two other stars. But these extreme objects will get into shenanigans with each other as well.
Oh yes. And this is where they were first detected by James Taylor and his graduate student whose name has escaped me, and I feel like a horrible human being. I am sorry, James Taylor's graduate student who went on to get a Nobel Prize. So I think it's okay. They discovered this work while they were at the University of Massachusetts, I think, and they were studying binary stars, and they found a system where the period of the system was evolving in a way that could only be explained if gravitational waves were carrying energy away from the system. Now, since that discovery, we have finally gotten gravitational wave detectors to actually work. Still bitter. Um,
Why you're
and
bitter? Uh,
there's
you're gonna have to at some point. You're just gonna have to relent and just give in. Like I can understand that it's gobbling up
I need
budget.
something to put fire in my belly.
Just
If this is what it is, it's a fairly innocent thing. So
So this is just the source of your rage is the fact that
exactly.
gravitational waves aren't delivering the kind of science you were hoping for as quickly as you would like.
It's just the timelines. It's the
Fine.
timelines.
Fine.
When you're told that something is supposed to be done by 2000 and it doesn't happen until 2010,
Just turned out it was hard.
I know,
All
I
right.
know. But
At some point, we need to
we
have some kind of party where you just embrace gravitational waves and we can just move forward. Maybe like a therapy. Can we have like a therapy session? I'll help you work through this. We'll talk about what happens next because there's
anyways,
lots of good stuff coming. Anyways, no problem.
anyways, it has been determined that compact off objects of a myriad of different masses are all periodically just going from being two objects to one in a release of massive gravitational waves and in some cases bursts of light. And that's the amazing thing is that we're able to theoretically channel all of the detectors of the world, from the particle detectors to the light detectors to the gravitational wave detectors, to do what is now being called multi-messenger astronomy, which
Right.
admittedly gives us one of the worst acronyms in
Yeah.
astronomy.
Well, we did a whole show on this.
And so go check out the entire
Yeah.
show.
Yeah.
Um, because this is the new extreme, except for the case of a supernova triggering another star to become a black hole. That to me is still more extreme,
Yeah.
but
Yeah. Well,
personal choice.
I mean, it's funny to me that hasn't been picked up by the news as big and as important as it probably is. So, I mean, maybe the findings, we're talking about the source of long period gamma ray bursts. I mean, 2017, we learned the source of short period gamma ray bursts being colliding neutron stars, but long period was still a mystery. Now it looks like we probably have we might have a serious answer for this, and yet I have been waiting for press releases to come out to talk about this, and nobody has. It's weird to
I
me.
think it's because it's plague times
Maybe.
and everyone has been distracted trying to deal with everything else going on.
Yeah, I think if true, is one of the biggest stories of the year. And yet so I mentioned this. I warned you that I'm going to steal your thunder and
That's
absolutely make a
okay.
video on this because it's so exciting.
I do the quick news, you do the in-depth
Right.
looks, we're good.
Yeah, well, no, just like normally I feel like I'm the one who sees this stuff, but you just nailed a huge story that was completely off my radar. So thank you. But just this, I mean, the fact that we can use these enormous black holes coming together in the final moments of being separate entities and watch how the space-time ripples outward, but even more kind of magical is with those neutron stars that we can confirm this collision in both the visible and in the gravitational realm is game changing.
We have in the past 20 years pretty much thrown out everything except for the basic dynamics in the astronomy textbook I started with.
Yeah.
Like the whole GMM over R squared, that is still true. But the story we tell of how objects interact with one another has been completely revolutionized as we've realized that space is mostly empty, but things find a way to interact.
Right. Yeah.
And it's kind of awesome.
Yeah, it really is. Cool. Super fun topic. I hope this gives everybody a lot of really interesting new rabbit holes to go down. Do you have some names for us this week?
I do. As always, we're just so grateful to have an audience of patrons out there who support us in everything we do. This is going to take me a moment to pull up. Rich, can you please edit this out? I when I realized we weren't simulcasting on Twitch, I had a sudden change windows,
Broke
and I
everything.
goofed myself. I'll have this in just a minute. Sorry, edits required. I goofed. I goofed. Almost there. Almost there. I had this all prepped, I promise. All right. So, as always, we would not be here without the generous contributions of people like you. It takes a lot of people behind the scenes, by which I mean two people, but two people we adore, and we like to make sure they can eat. Um, Actually, it's more than two nowadays. It takes a whole bunch of people behind the scenes to make sure we do everything we do. This episode is going to be produced by Richard Drum. We're going to have all of our show content put together by Beth Johnson. Ali Pelfrey's in the background, making sure all of our YouTube channels just stay on target. And we're able to pay our humans a fair wage because you support this show. Thank you. And this week in particular, I would like to thank Ryan James, Brian Nelson, Kristen Brooks, Eric Ferenger, Martin Dawson, Kensia Penflico, Dwayne Isaac, Frodo Tenenbaum, Shannon Humbert, Justin Proctor, Thomas Tubman, David Gates, Rachel Fry, Irin Segev, Frederick Jorg, Claudia Mastriani, Neuter Dude, and Paul L. Hayden. Thank you, all of you, for everything you do that allows us to do everything we do. We are indebted to your support.
And we'll see you all next week.
And now we save.
571. Oh, I gotta clean off my hard drive. You get to this point where you're not sure they'll save because your hard drive is so full.
I get that.
Rich,
I get that.
oh, Rich Wilson. What I'm hearing? What's this I'm hearing about absolute proof of an alternate universe? Just give us a second, Rich, and we will dig into that. Because that's going to be like Pamela's favorite topic.
So not my favorite topic. The poor scientists on that result, I feel for them. There's certain things you don't want to have happen in your career, and this is one of them.
Yeah, I will definitely want to look into the. I'm gonna look at the paper and see, but it is pretty funny.
All right. So.
Stop. Okay. Don't upload. Just wait.
Am I uploading? I am uploading. Pausing that. No, I'm not uploading.
Okay.
Wait, yes, I am.
Okay.
So many different windows to check. All right. It's paused.
Don't worry about it. Well, then you'll forget to unpause it. Don't worry about it. Just keep it going. It'll only take a minute.
That's true. I did totally forget to unpause it last week.
All right. Let's talk about it. Let's talk about this. He says in his Canadian accent. Let's talk about this.
So the New York Post, the source of reputable science journalism, had a story that ran this week on how a team of NASA scientists had discovered a parallel universe in which time runs backwards. Now, given that it's plague times in 2020, a lot of us are kind of wishing we could run that time backwards and try a different option in our current choose your own adventure.
Right.
Maybe even roll things all the way back to like 2015.
We saw a Rick and Morty episode that just covered this with horrible results. So
yeah. Now, the thing is, first of all, you can call me a NASA scientist, and NASA would not like you to call me a NASA scientist. And the reason is I am funded by NASA, but I don't actually work at NASA.
Yeah, you don't have a NASA email address. That's the key.
I don't have a NASA badge. I just happen to have funding from NASA.
Yeah.
And it's to write astrometry software. So,
yeah.
Anyways, some researchers who happen to have NASA funding.
Like you.
Like me.
Right.
Like a lot of people.
Yeah.
Not unusual to have NASA funding at all.
Yeah.
completely normal.
Normal.
We're looking at data from a neutrino detector and saw some neutrinos that had some out of spec, we'll put it that way, out of spec energy readings. And there's basically three different ways that you can explain the things that they were getting. Systematics, this is just there's something in the system where everything is a little bit off. There was a result a few years back from CERN where they accidentally detected a particle moving faster than the speed of
Right. I
light.
remember that.
Something wasn't plugged in correctly. That's all it was. So it could be systematics. It could be something in the system that is leading to this result.
Right.
It could be something having to do about the location of the detector, where perhaps interactions with the extraordinarily thick ice in Antarctica is channeling the neutrinos in a different way, focusing the light in a different way, not the light, focusing the particle in a different way that appears to give it a higher energy.
Right.
Or it could be an astrophysical effect, which doesn't have to mean parallel universe with time running backwards.
Right.
But there are theories among us. And again, put 5 theorists in a room, they'll come out with 8 theories.
Sure. Yep.
There are theories among us that say this kind of a detection can evolve from a parallel universe with time running backwards.
Right. So can you just explain what would be happening? Why would we be receiving neutrinos from a parallel universe where time is running backwards?
Well, so there's
Like,
ideas
why is that
out.
something that occurred to them to say this could be the cause?
Well, there's always people out there trying to figure out how do we detect if we live in a multiverse? What are some of the possible couplings of particles? What are some of the ways that things can leak from one universe to the next in a
Right.
multiverse? This is a favorite sport among theoretical cosmologists of the multiverse variety.
Right, right. And this is this idea of violation of what's it? Time, spin. What do you call that?
Direction of time, arrow
Yeah,
of
the
time.
with the three thing, the
Oh,
CP
CP.
CP violation, CPV. Hold
Yeah.
on.
Parity, color. These are the different parameters that go into these
Yeah.
particles. I'm an observational
Yeah, yeah,
astronomer.
yeah. Yeah. So
Um,
I think it's CPT violation. So essentially, if I understand correctly, um, if you change the charge of everything in the universe, it doesn't work. If you change the parity of everything, if you change the symmetry of every particle in the universe, it doesn't work. But if you also change the time, so if you and run time backwards, then it works. Then you can run the
yeah.
universe backwards and forwards, and everything is fine as long as you're willing to change the, turn everything into antimatter and then make everything symmetrical and then run time backwards, then the rules of the universe work in both directions. And so if there was a way that you could see that, maybe you would see these neutrinos. That was sort of my understanding of how this would work. And so I guess, I'd love to understand the story. It's almost like I want to do a story about how the person at the post put this together.
Yeah. And I'd bring in Dr. Katie Mack for color commentary.
Well, I was gonna, yeah, or any of them. Talk to Paul Sutter, talk to uh, Ethan Siegel. Any of them will have a will.
Well, so Katie's still doing research in this field. She's an active cosmologist.
Ah, okay.
And one of the things that she pointed out was, look, if a story comes out like this and you look at Twitter and all the active cosmologists in the field that you follow are not having a complete freak out of joy and happiness in science, she didn't phrase it this way,
Yeah,
I'm
yeah,
paraphrasing. If you do not see active Twitter happy cosmologists, it's not real. This is not real.
yeah.
The cosmology community is not amused.
I actually joked with her about this on Twitter and said, yeah, because it's usually dust. And she was like, too soon. So, I can just I can tell any astronomer who's discovered anything that it's probably just dust. And they'll just sadly, slink away knowing that I'm right.
Or a magnetic field.
Or,
It's one of the
yeah,
one
it's,
or the other
yeah,
of
it's a
those two
magnetic. Yeah,
things.
if it's a magnetic field, you still won't be able to calculate it. But if it's dust, you're like, oh yeah, it's dust.
Yeah.
Because it's always dust. It's always been dust. So
And dust likes to eat cosmology
yeah.
discoveries.
How big is the universe? Oh, turns out it was dust. What's causing tabbies? Oh, dust. Right. By B mode gravitational wave. Oh, dust.
Yeah.
So yeah, it's always dust. Um, yeah, it's always so funny. But yeah, I should definitely talk to Kia. Well, I can't even. I'm sure she's just gonna be. She'll just be like talking to someone just raging. So I think I'll wait. I'll talk to someone else about this one. Someone who isn't. Yeah, clearly this is just swirling around her right now, and she's trying to just promote her book. She just wants to tell people at the end of the universe. That's all.
It's true. It's true.
So thank you, everybody. Sorry that that's all we got to talk about this week, but I think it's important work to just absolutely smother out any possibility that astronomers have detected other universes.
Still not there,
We
folks.
talked
Still
about
not there.
the source of gamma ray bursts. We talked
We
about
did, and it
stars
is
consuming other
awesome.
stars. Yeah. We went to places your imagination can scarcely contain. You don't need You don't need other universes yet.
Yet.
Yeah, of course. I'm leaving that open. Are you kidding me? Where can people watch Pamela related activities coming up soon?
So this weekend, I am going to be doing two presentations for virtual Balticon. Go to balticon.org if you're hungry for your sci-fi, fiction, fantasy conventions that all of us are missing this weekend. As far as I know, both Balticon and WisCon are taking place as normal, but via your internets. So check that out. As always, we have the daily space going on, and just follow along. And if you need more podcasts to get you through the summer when everyone else is going on hiatus, Daily Space is not going on hiatus. So check us out, dailyspace.org, or look for the Daily Space wherever you find podcasts.
So, of course, we're going to have our next virtual star party on Sunday night, and it will be a continued mixture of people yakking about space and sharing views from telescopes. So, join us on my YouTube channel Sunday night.
Broken Symmetry just wrote in the Twitch chat, honey, I think we need to see other universes.
That's awesome. All right. Well, thank you everyone for watching us today. Thank you to all of the moderators. Thanks to everyone both on YouTube and on Twitch. We see you. See, Pamela saw you. We really appreciate all of your support. If you want to be more active, and remember, if you want to hang out with other like-minded people during the dark times, go to wshcrew.space, and they will keep you your mind together for the 2 months while we're on hiatus with Astronomy Cast and Weekly Space Hangout. And everybody, I hope you stay safe and are able to continue doing learning and improving yourself and learning about the universe so that when you can actually leave your house and get out there and explore again. Thanks, Pamela, and we'll see all of you
Thank
next
you.
week.
Okay. Bye-bye, everyone.
And the